In this module, you will learn about laws of chemical combination. After a series of experiments, Democritus concluded that if you continue to cut a stone into smaller and smaller pieces, at some point you would reach a piece so tiny that it could no longer be divided. Democritus called these infinitely small pieces of matter atomos, meaning indivisible. Convinced that matter is made up of tiny indivisible particles, many scientists like Evangelista Torricelli, Daniel Bernoulli, Joseph Priestley, and Antoine Lavoisier started studying the natural world. Among them, Joseph Priestley discovered that substances could combine together or break apart to form new substances. Later, Antoine Lavoisier, from his experimental observations, established a law that states that there is no gain or loss of mass when new substances are formed. It means mass can neither be created nor destroyed in a chemical reaction. This can be better explained with the help of an experiment. To do this experiment, place a watch glass on an electronic weighing machine and set the reading of the weighing machine to 0 by pressing the tare button. Take 7 grams of iron filings in the watch glass. Similarly, take 4 grams of sulfur in another watch glass. Now place a china dish on an electronic weighing machine and set the reading of the weighing machine to 0 by pressing the tare button. Transfer the iron filings and sulfur from watch glasses to the china dish and weigh it. The weight is 11 grams. Take out the china dish from the weighing machine and mix the iron filings and the sulfur thoroughly. Arrange a tripod stand with a wire gauge on it. Place a Bunsen burner below the wire gauge and then place the china dish on the wire gauge. Light the Bunsen burner and heat the mixture over the Bunsen flame. It forms a dark molten mass of ferrous sulfide. Weigh the mass of the ferrous sulfide and you'll find the weight to be 11 grams. This shows that the mass is the same, though there is change in form. Therefore, the law of conservation of mass can be stated as the total mass of reactants is equal to the total mass of products. This led scientists to ponder over the combination of substances, and they conducted various experiments. All these observations were accepted and the law of definite proportion was proposed by Proust. Proust, a French chemist, concluded that when 100 grams of water was decomposed, 11 grams of hydrogen and 89 grams of oxygen was obtained. He later purified and analyzed numerous compounds and concluded that every pure substance contains the same elements combined in the same proportions by weight. So, the law of definite proportions can be defined as, in a chemical substance, the elements are always present in definite proportions by mass. Basing on Proust's observations, John Dalton further researched and realized that water could exist as a gas that is mixed with air and occupies the same space as air. Solids cannot occupy the same space as gas. For example, ice cannot mix with air. This made Dalton ponder over what could allow water to sometimes behave as a solid and as a gas at other times. After a series of experiments with various substances in different states, Dalton concluded that all matter must be composed of tiny particles which cannot be further divided. He called them atoms. So, an atom can be defined as the smallest particle of an element. According to Dalton, all matter is made of atoms. Atoms are indivisible and indestructible. All atoms of a given element are identical in mass and in properties. Compounds are formed by a combination of two or more different kinds of atoms. And a chemical reaction is a rearrangement of atoms. Atoms of different elements have different masses and chemical properties.